All right. So now let's look at the 10th sutra, Yavadunam, right? Pronounced again as Yavadunam, Yavadunam. And the English translation of this is whatever the extent of its deficiency, whatever the extent of its deficiency. So again, welcome to the 10th sutra lesson, right? And so this sutra, provides an elegant method for calculating um, powers of numbers that are close to convenient bases, right? By working with their deficiencies from that base. Okay. So in authentic Vedic mathematics, right, this sutra reveals a profound understanding of numerical relationship, like any other sutras we have gone through, right? So the Sanskrit term Yavadunam literally means whatever the extent of its deficiency, and represents a principle where the distance from a convenient base determine the calculation method. So the ancient sages recognized that numbers close to round bases follow predictable patterns when squared or cubed. So this insight transforms complex calculations into simple operations based on the deficiency values. Okay. So let's look at the first example, right, which is square of number near base, right? So in this case, it is square of 97, which is the near base of 100, right? So if you look at, you know, the first step is, find the deficiency. Yeah, find the deficiency from the nearest base, right? So this is 97 is under nearest one is 100 base. So that means it's 100 minus 97 is 3, right? So that's step. So the Vedic approach to squaring numbers near a base reveals the elegant mathematical thinking of ancient sages. So rather than performing the full multiplication, they recognize that the deficiency from a convenient base creates a pattern that can be exploited. Okay. So this method transforms a complex squaring operation into two simple calculations, right? Subtracting the deficiencies from the original number and squaring the deficiency itself. So this insight dramatically simplifies the mental calculation. Okay. So we know the deficiency is 3. So the left part, which is here 97, so you subtract the deficiency from the number. So 97 minus 3 is 94, right? So we start again, base 100, deficiency is 3. The left part is 97 minus 3 is 94. Okay. And like I said, the next part of that is the right part is basically you take that deficiency of 3 and you square that, that is 0.9, right? So what is the result? You put the left part and next to it you put the right part. So that's 94 and 0.9. So the result is 9,409, right? Take a minute to digest, right? Taking a number like 97 squared close to the base of, in this case, 100. So you find the deficiency, which is how much less than 100 is 3. And then you take that, and on the left side where you have 97, you subtract 3, 94. And on the right side, you square the deficiency, which is 9. Okay. So again, this is the whole concept of all the sutras is to recognize the patterns and then execute by simplified multiplications and subtractions, right? You can take complex mathematical equations or numbers and operators and solve it easy. Okay. Similarly, let's look at 98 cube, right? So 98 to the power of 3, right? So in example 2, it's a cube base. So cube near the base. Again, 98 is near the base, okay? So what's the deficiency? 100 minus 98, 2, okay? Again, just, to understanding how this works, right? So Yavadunam and to the cube demonstrates the systematic nature of Vedic mathematics, right? So Yavadunam kind of will look at the cube part of it. So that the ancient sages discovered that the cubing numbers near a base follows a predictable three-part pattern based on the deficiency value. So this insight reveals the deep mathematical understanding of the Vedic traditions, where complex operations are transformed into structured patterns that can be easily applied. So this method scales elegantly even for higher powers while maintaining its simplicity, right? So as first step, we found the deficiency, and then the first part is you take again the left side 98, and now this is cube. So instead of just subtracting it by the deficiency minus 2, you multiply 2 times 2, 4. So you subtract 4, so twice of the deficiency from 98. So that's 94. So the subtract, right, of the deficiency. So as you can see, 98 minus 2 times 2 is 94, right? So now you take, as the next step is, instead of on the right side, now you know the deficiency is 2. So what do? You actually do the cube of 2. So 2 times 2 times 2 is 8, right? So you have uh, 0, 8, right? So the first part is you take 98 and you subtract it by twice the deficiency because it's a cube. So that's 94. The second part is you take the deficiency and you multiply it by the deficiency itself, 4. So that's 0, 4. And the third part is you cube it, 8. That's 0, 8. So now the result is you put all three of them. So as we said earlier, it's a three-step process. So 94, 0, 4, 0, 8. So 94, so 940,408. So that's the answer for this. Okay. So as you can see that how easy it is to solve squares and cubes of numbers which are close to the base, right? So again, Yavadunam teaches us that the extent to a number's deficiency from a convenient base, provides the key to efficient calculations, whether squaring or cubing. This method, applies to both of them, right? So transforming complex arithmetic into simple operations based on deficiency patterns. So the greater the deficiency, the more it influences both the structure and calculations of the result, right? So again, the Vedic insight we have explored reveal the profound mathematical understanding of the ancient sages who recognize patterns and relationships that simplify calculations. These principles continue to offer elegant wisdom of Vedic mathematics. Okay?